Alright, welcome Statistics 1 students to week 9 of maintenance. Only got a few questions today, we'll see how we go with these. The first one, in the representation of data section, we have the amounts of money in X dollars that 24 people had in their pockets can be summarised by the sum of X take away 36 is equal to 60, and sum of X take away 36 squared is 227.76, and we've just got to find sum of X and sum of X squared. Okay, well, okay, well, the first thing I'm going to do here is I'm going to use the fact that the sum of X take away 36 is equal to 60. So to find the sum of X, I'm going to take that negative 60, and then I'm going to do plus 24 times 36. And this ought to equal the sum of X. Now the reason for this, of course, is that if you look at the formula here, for every X value, every of those 24 X values, I've taken the X value and I've subtracted 36, and when I did that, I ended up with minus 60. So to get back to what sum of X is, I've just got to simply add those 36, the 24 lots of 36 that I've subtracted. So, of course, when I do this, what do we get here? 24 by 36 is 864, and then we've got that negative 60, so it should be 804, I think. Okay, so that's that one. Now we need to think about how we're going to get the sum of X minus 36 squared. So I guess what we can do here is we can use the fact that the standard deviation, or the spread of the data, is going to be the same when it's coded and when it's uncoded. So I'm going to use the standard deviation formula here, or maybe I'll just even use variance. So the variance of the coded data was just going to be the sum of X minus 36 all squared over the number of items of data. What did we say that was? 24, eh? Take away the mean of the coded data squared. Now the mean of the coded data is going to be this negative 60 divided by 24, which gives me negative 5 over 2. So the next line, we can start chucking some stuff over. Negative, and it's negative 5 over 2. We're going to square that. And then we know that's 24. The top of the fraction is 227.76. And so this will give us our variance, which should be the same for the uncoded data as well. So let's just chuck this into our calculator and see what we get. Minus I'm getting 81 over 25, or 3.24. And since the coded data isn't changing the spread at all, because we're just shifting things by minus 36, that means that we should have sum of X squared over 24 minus the new mean, because the mean does change. It's going to be this divided by 24. And we square that. And this should also be equal to 3.24. And then we can solve for the unknown, which in this case is our sum of X squared. So what do we do here? 3.24 plus, and then 804 over 24 squared, and then times that by 24. So I'm getting 27,000 27,011.76 would be my answer there. Hopefully that makes sense. Okay, so the next one is also representation of data doing a stem and leaf diagram. We've got the prices in dollars of 11 caravans in a showroom, and we've got to represent them on a stem and leaf diagram. So what is our lowest value here? It looks to be this one here. So I might just write in my stem part, I might just go down like this, 14, 15, 16, 17. Okay, and then I'll go 3. Is there any other 14s? No, let's go to the 15s. There's a 15.5 and a 15.3 and a 4. 3, 4, 5. And then we go to the 16s. We've got a 16.100. We've got a 16.400. And then a 16.800, 800. Like so. And then we got a 17.3 and a 17.7. And then we got an 18.5. Okay, now when you're doing these, you've always got to show your key. So okay, I would write it like that. So I've got my key. I think that's probably fine. Now everything's in order. And the lower quartile of the prices. Okay, so first we'll find the median. There's the median. There's 11 items of data. So the sixth piece of data, you go 11 divided by 2, which is 5.5. So you're looking for the sixth item of data. The sixth one is going to be the median. So you count in order, don't you? 1, 2, 3, 4, 5, 6. So this is our median. And now if we're looking at the lower quartile, we're only going to be focused on these 5. And so the middle of that group of 5 is the third piece of data, which is this one here. So our lower quartile price is equal to $15,400. Okay. Now the next part of the question is 3 different caravans in the showroom are chosen at random and their prices are noted. Find the probability that 2 of these prices are more than the median and 1 is less than the lower quartile. Okay, so what's the chance of getting a price higher than the median? Well, you can see higher than the median, you've got 1, 2, 3, 4, 5 options out of 11. So your first chance would be 5 out of 11, I guess. And then you pick your next one, 4 out of the 10 that are left. And then you've got to have one that's less than the lower quartile. So it's more, and then less than lower quartile. And so less than the lower quartile, there's only 2 options out of the final 9 at that point, wouldn't there be? You can see the 2 options are, of course, this one and this one. Okay, now I think find the probability that 2 of these prices are more. Okay, now you can see that there's a number of different ways that you could do this, right? So you could actually go more than the median, less than the lower quartile, more than the median, or you could go less than the lower quartile, more than the median, more than the median. So there's 3 different ways you can do this. So I'd probably just multiply this by 3, and that will give me the different options. So let's just see what this works out to be. Hopefully I haven't made any silly errors and logic here, but I think that's probably what I'm just going to do. I get 4 over 99 as my chance that will be fulfilled. Oh, that's not actually 4 over 99. I need to times that by 3, so that'll end up being 4 over 33 is the final answer. Alright, we can move on. The next one, the last one for the day, is Anna is meeting some friends every day. And for each day, the probability that she is early is 0.05, and the probability that she is late is 0.75, otherwise she's on time. Okay, so we go, this can be early, this can be on time, and this can be late. So this is 0.75, 0.05 early, so it's one of those ones, and so this must be 0.2. Now, if she is early, there's a probability of 0.7 that she will eat a banana. Okay. Banana, 0.7, which means not banana, must be, 0.3. Okay. If she's late, she does not eat a banana. Okay. No banana. So, 1. And if she's on time, there's a probability of 0.4 she will eat a banana. 0.4. Banana. And then 0.6. No banana. Okay. Now, given that for one particular meeting with friends she does not eat a banana, find the probability that she's on time. Okay. So what we're trying to find out is the probability of on time given no banana. Okay, so I think for this we're looking at the probability of on time intersecting with no banana all over the probability of no banana. Okay, well, so on top we're going to have this bit here, okay, which is 0.2 times 0.6, and on the bottom we're going to add all of the different ways that she can have no banana. Okay, and this one as well. So you can see we'll have 0.05 times 0.3 plus 0.2 times 0.6, and then plus 0.75 is the last one there. Now, when we pop this onto our calculator, what are we actually going to get? That's a funny number. I've obviously made an error because I got higher than 1. Oh, I think I've known what I did. Plus, no times there. Okay, I'm getting 8 over 59 for this. 859, 8 over 59, or 0.136. Alright team, well I hope that's been helpful, hope it makes sense to you. Let me know if you have any questions. Keep plugging away at these. We're going to start introducing some new types of questions soon as we finish new chapters in our textbook. See you later.